Mr. Pants.
I saw it the first time.
I did
Maybe
it.
I hit it on accident. Jack, way to be watching for that. We are back, live and back. Oh yeah, you hear all your voices.
Yay!
Hi, Catherine Smale.
What's my name?
A shout out to Catherine Smale. All right. So y and f of x can be replaced with each other. When are we going to use f of x, people?
Every time.
No.
When there's only one x.
No.
Equals mx plus b. When y equals.
When it says function, always remember that function notation. The function notation starts with an f, so I'm going to use f of x then. Okay? Again, you guys will see this a lot over the next couple of years. You will get good at it. All right. Now, we're going to find each function rule. This is the first part of your homework. Okay? I'm going to read the first one to us, and then you guys are going to try to read B and C to us.
Okay.
So listen to what's going on here. Here's how you say problem A. You're gonna find f of 2 if f of x equals x minus 4. That's how you say it. All right? What we're going to do, whatever number is in the parentheses, in this example, f of 2, we're going to take 2, and guess where we're going to replace it? We're going to replace that in for x. It's that simple. So here's how we write this. F of 2 equals 2 minus 4. I'm going to take that 2 and plug it in, throw it in for my x. Don't try to distribute your f. Don't solve for f. Just replace your 2 in there. So, watch this. F of 2. We do not need a calculator for this, I sure hope. Guess what f of 2 equals? Negative 2. Because 2 minus 4 is negative 2.
Is that the answer?
That's it.
Really? Is that our only thing?
Yeah, that's the only thing we're going to do today.
Really?
Oh, that's sarcasm. Yes, there's a lot to do today.
Aw.
All right, let's try the next one. B. Somebody try to read B from left to right. Say it the right way. Try it, people. You're not going to get good at it unless you do it. Harrison McConnell, give it a shot.
F of 12. Wait.
Say find f of 12.
Find
I should
f
put the word
of
find
12 if f of x equals 1/2 x plus 3.
Well said. We're going to find f of 12 if f of x equals a half x plus 3. So, all we're going to do is take our 12. We're going to write f of 12. And we're going to say it and we're going to think about it. F of 12. We're going to plug the 12 in for what variable? X. We're actually going to, when it says 1/2 x, what operation does that mean? Multiply. So we're going to do a half times 12, and then we're going to add 3 to it at the end. Okay, again, I hope we can do this without a calculator. Raise your hand if you know what a half times 12 is. Without a calculator. Maeve, how much is it? 6. Half of 12 is 6. Maeve, add 3 to that number.
9.
Guys, f of 12 equals 9.
Fancy.
Okay? This is different from what we've done. You know, just a different way to write. We've done a lot of this stuff, guys. We're just writing it a little differently. All right, who wants to try to say C?
I do.
Say it left to right.
Oh, wait, no, I don't.
Come on.
Wait.
How do Cal say it? Say find.
Find f of negative 3 if f of negative 3
We want to say f of x.
F
We
of
are going to
X.
put negative 3 in there.
equals 2
X.
2x plus 1.
Right. You just said the problem. Everybody take negative 3 and plug it in for x.
Okay.
And then do the math. Go. Allie, what do you got? Of?
F of negative 3 equals negative 5.
I got negative 5. Talk me through it. Like,
Equals negative 6 plus 1.
which is?
F is negative 5.
How many people got negative 5?
I did.
Okay. Part of your homework, guys, is just finding the value for a certain value for a certain number, and you just plug the number in. The other part, just do the math. But it's all about how you write it. And we're writing it in what kind of notation is this called?
Function.
Function notation. You guys can do this. Harrison.
What does the F mean? Like,
Function.
means function.
Great question. Great question.
Function of x.
A function of x. Or a function of 2, a function of 12, and a function of -3. Guys, this is gonna, something's gonna happen in the next couple days where you guys are gonna go like, oh, this is what this means. So make sure you're doing this stuff now, and it'll all come together at the end. All right, jump to the next page. It does get a little more difficult.
There's still
Wait,
Oh, is it?
remember? Yeah,
Yeah, there's still
Oh,
the
sorry.
bottom.
Oh yeah, we gotta fill in that.
we're gonna be adding domain and range.
All right,
Oh man.
we're gonna organize the. Do you guys remember doing like when you were like in 2nd or 3rd grade doing input output?
Yeah.
Yeah.
Things.
I
You
remember
input a
that.
certain number and a different number output comes out. Okay, that's what we're gonna be doing just with more difficult algebra stuff. So we're gonna organize our inputs. You guys are gonna decide what inputs to put in. You're gonna have some kind of rule that you're gonna input in. An output's gonna come out, and we're gonna do this into a function table. Do you guys like making tables or not?
Yeah.
Eh.
No. Work is
If they were like
down.
a table form.
Okay. Yeah, if the table's made for you, it's nice, but you guys have to make your own table. Sorry.
Oh boy.
All right.
I made a table. And what's
You can organize your input rule and output into a function table. Now, the variable for the domain. You guys remember domain from yesterday or not?
Yeah.
What variable is domain?
X.
X. Everybody say it. Domain is?
X.
Domain is the X.
Yeah.
That's going to be your input, your X or your input. That's called the independent. Write small. Independent variable. X is always your independent variable. Okay? Do you guys consider yourselves to be independent?
Kind of.
No.
Good, great answer, Maeve. Kind of. You're getting there, right? Are you more independent now than you were 4 years ago?
Yeah.
Yeah. You're allowed to do way more things. You're more independent than you were a couple years. But how many of you guys think you could walk out your front door forever and survive?
I could.
Pedalcom might be the only one in here that can do it.
I could do it.
So.
Because I get a job.
Who's gonna hire you?
I have my resources.
Yeah, you're probably right. So, guys, you guys are dependent, right? The opposite of independent is dependent. Who are you dependent on right now?
My mother.
Yeah, mom and dad. Okay, whoever you live with. You are dependent right now. Okay? So, the X is the independent variable because it can be any number you want. You get to choose X. It's independent, doesn't matter. But the variable for the range, which variable, guys, is the range?
It's Y.
Why?
Because I
Because I
said
said
so.
Said so, exactly. The variable for the range is the Y or the output, and that's called the
Dependent variable.
dependent variable. Y is your dependent variable because it depends on what you put in for X.
Yes.
Once you do a couple of those examples, you'll start to understand why X is independent, Y is dependent. All right, let's make a function table now. Let's do this.
Function.
All right, here's a function table. You were going to have to draw this in your homework. Okay?
Oh,
It's just
man.
you don't have to use a straight edge and make it nice and pretty like a. You could totally do this, guys. Okay, make it quick. Doesn't have to be perfect. Doesn't have to be perfect. You do have to label it though. All right, you're going to choose 4 values for X. That's the input. That's the domain. That's the independent variable. You guys get to choose 4. And I'm going to lead you down the right path at first. Okay? And then you're going to make a function table, this thing. And our function for this problem is f of x equals 3x minus 1. This is that whole input-output thing that you guys used to do when you guys were in 3rd grade. Okay? Then you're going to state the domain and the range for this function. Okay? All right. Domain is always going to be your left column. That's domain in your x. That's the same thing. You get to choose values here. We're going to do some math here in the middle, and then we're going to get the range. We're going to get the output or the dependent variable over here on the right. All right, I left this blank. You always put in your function rule here. So for this case, f of x equals 3x minus 1. You got to fill that in. Whatever the problem is, the function rule, throw that in the middle. All right. We get to choose our own x. Should we choose like 571?
Yes.
No.
Do 9.
1, 2, 3.
9.
What's the smartest x or input to choose?
3. 3.
0. Makes your life easy. Okay. Oh, you don't have to. I always say choose 0 first. When there's multiplication involved, guys, things are going to, timesing by 0 is going to make 0. It's going to make things easier. What would be the next smartest x value you should choose? 1. Keep it simple.
132.
2.
96.
You have to choose a negative
Got it
value.
Negative 5.
Negative 0.
Negative
There's no such thing as negative 0. Good try, Harrison.
Negative
11.
1.
Negative
7.
1. Oh, guys, if the coefficient of the x is a whole number, which it is in this problem, choose 0, 1, 2, and negative 1. If the coefficient of the x is a fraction, then you're going to have to make some better decisions. Like if there was a half in front of the x, I would choose even numbers because I could take half of even numbers pretty easily. If the coefficient's like a fourth, I would choose multiples of 4 because those will work out nice and neat. But anyways, when you get to the tougher ones, you'll make those decisions. Now, this is just a sneaky way. Everybody put 4 fingers up in the air.
4.
Maeve's sitting there like this. Put 4 fingers up in the
Yeah, I
air.
don't hold the 4 fingers.
This is just a sneaky way to make you do 4 problems at one time. Okay? What you're going to do is you're going to find f of 0 first. Then you're going to do f of 1. Then you're going to do f of 2. Then you're going to do f of 3. F of negative 1, not 3. So, remember how we do this. 3 times 0 minus 1. Raise your hand if you can do that totally in your head. What's f of 0?
0.
Negative 1. Explain how you got that, Catherine.
3 times 0 is 0 minus 1.
Now you're going to do f of 1. Start all over. 3 times 1 minus 1. Okay? Who do that in your head?
2.
Chill.
Love the enthusiasm, Helicopter. It is 2. 3 times 1 is 3. Minus 1 is 2. Now do f of 2.
Oh, I see that.
3 times 2 minus 1. Angie asks, how much is that?
1.
It's not 1.
It's 5.
What's 3 times 2, Angie? Don't be mean. Don't be mean. Angie, 3 times 2.
5.
Minus 1. 5. I got 5. Okay.
I
Now.
thought I saw a pattern because it's going negative 1 and 2.
Ah. Okay. I appreciate you were looking for patterns. That's good math. All right. F of negative 1. Be careful with your negative signs, people. Rothstein, how much is f of negative 1? Sorry, I did not mean to wake you up. What's 3 times negative 1?
Negative 4 minus 1.
What's 3 times negative 1? Negative 3. Minus 1. Negative 4.
Wow. Alright.
Maybe we need a calculator, Em. Okay, be careful with your signs. All right, so this is it took us a while to get through this. When you guys start doing these, you will zip through these in like less than a minute. That's how good you'll get at it. Show your work. Okay. Now you have to state the domain and the range.
Yay.
Even though they're listed here, it's easy. Remember, domain we do with a capital D. We make those nice little braces. Okay. Pavone, what's the domain of what we chose there?
0, 1, 2.
Nice. You totally could have done a different domain. If you chose different values, you'd have different domain, and then you'd have a different range if you chose different values, obviously. Trace, give me the range.
Negative 1 to 5, negative 4.
Nice. Just to get you guys in the habit of knowing what the domain and the range are.
Is this what I'm
we don't have to do anything like this in our homework.
It's for our health.
Catherine, I know you are, but you know the answers to those questions. All right, now the hard part. Go ahead, Ann.
For the other one, when it's listed, negative one in the domain and you just have to put it in the domain.
Say again.
Because negative one is listed twice in the domain and
But it's not listed twice in the domain or in the range.
But last time I was like that, you said we only put negative.
But that was only if it's listed twice in the same word, in the domain or in the range. But yeah, if it's in both, you have to list it in both. All right. Okay, next, we're going to talk about these independent and dependent variables. All right. I did the research, people, and there's about 770 peanuts in a jar of peanut butter.
Really?
Yes.
It's amazing.
I just made that up. I'm lying.
Yeah, no,
Okay.
I was like, yeah.
The total number of peanuts, okay,
So
we're gonna call that, because it's a function, okay, we're gonna call it, instead of f of x, we're gonna call it p of j.
Uh-huh.
Last period we wanted to call it pb and j, but it is not pb and j, okay? It is p of j.
It's called
Let me say it.
PJ.
What
Pajamas.
p of j stands for the total number of peanuts, is a function of the number of jars of peanut butter. Okay. And guess what variable we're gonna use for jars of peanut butter?
J.
PB.
J. Notice that p of j and j, that's how this function stuff works. They gotta use the same variable. Alright, now here's the deal. You gotta identify the independent and dependent variables. Label them, you can totally abbreviate it, people, it's no big deal. There's the independent variable, there's the dependent variable. Alright, the independent variable is our x. Okay? What you guys normally use is the x, and the dependent one is our y, usually. Okay? Now, this is tough. Which quantity or which word depends on the other? What I mean by that is,
Why?
say it both ways. Do the number of peanuts depend on the jars, or do the jars depend on the number of peanuts?
Jars depend on peanuts.
Say it again.
Peanuts depend on jars.
Which way?
Either way.
Makes more
Peanuts
sense.
dependent on jars.
No, jars depend on peanuts, because without the peanuts, it's going to be an empty jar.
Wait, here's my question.
Without the jars, then there's no peanuts.
You can just put it on the
No,
floor.
no, this is a good way to think about it. Look at the numbers.
There's a lot of peanuts.
Which quantity, either peanuts or jars, could you not have a certain amount of?
Jars.
Peanuts.
No, you could have any amount of jars.
Peanuts.
But could we have 780 peanuts?
Yep.
Yeah.
No, we couldn't.
Why?
Because you've got to have the amount of peanuts got to be multiples of 770 for depending on each jar. If we have one jar, we have 770 peanuts. Can we have 2 jars? Yes or no?
Yeah.
Yes. How many peanuts would we have?
770.
14.
No.
Four,
770s.
1,440.
90.
1,540.
Yeah, 1540. Okay. So here's my question: can we have 780 peanuts?
No.
No. Okay. The peanuts are totally dependent on the number of jars.
Well, you can put tons
So
of
our
peanuts in one
independent is our jars, or instead of using x, the problem told us to use the variable j. It's just that x is always our independent variable, which means our dependent variable, peanuts depend on how many jars we have, which we know to be p of j. They told us that in the problem.
Didn't we do this last year?
I don't know if we did this last year.
It was like with the cards and the chips.
We might have.
The independent.
If you remember it now, that's great.
I
Then
know.
that's good. Again, this is another concept, guys, you'll do every year. And it might not be that clear right now. Stick with it. Keep trying. You will get it.
Like we did like the
All right. Let's talk about the values for the domain and the range. Oh, and the independent is this is the domain. And the dependent is the range. So, for the domain, which is our jars, What could the values of the jars be?
1,
What else?
2,
What else?
3.
Could it be
Infinity.
1.5?
No.
Guys, can you go to Jewel and buy 1.5 jars of peanut butter?
No.
No, you
Maybe.
can't buy a half jar.
Break a jar.
Unless you get like the
No,
smaller
you can't
pack.
break a jar and buy it, Matt. That'd be weird.
Unless you get
Or
like
you
It'd
the
be
can like
smaller
cheaper.
open
pack.
it, eat half of it in the store, and then buy it.
That'd be even weirder. Okay,
That'll be illegal.
you cannot buy a half of a jar of peanut butter. Right, you can buy the little one, but that's still considered a jar. That's a good point. Okay, but it's still a jar. So,
If you couldn't have
the jars, you could buy, could you buy 0 jars of peanut butter?
Yes.
Yes. Could you buy -1 jars of peanut butter?
No.
No,
You
that's
can
not,
give them a jar of peanut butter.
that's not that's not a value that you can choose. So, we're only going to go whole numbers. Jars, those are the only things you can have. You can only have 0, 1, 2, 3, 4, ... all the way to infinity.
No. Well,
Okay.
until they run out of stock.
There's not that much peanut butter in the world. You're right about that, but just for now.
Or in one
So for
store.
peanuts, or our dependent variable, what are the only values you could have for this? 770,
1540.
1540.
That's all I know.
Oh, yeah, the next ones I don't know what. How about this? Can we write it this way? Multiples?
2310.
No.
Yeah.
Multiples of what?
770.
770.
Well, 7.
Could you have 0 peanuts?
Yeah.
Could you have 770 peanuts?
Yes.
Yes.
Yes. Okay. Nothing in between.
What if you have 770? Wait, no.
1.
769 peanuts.
You can't.
Yeah, you
Why?
can. It'd just be a little bit of an empty jar.
You got gypped on that jar of peanut butter, I guess. All right, let's write the function rule now. Okay? Here's the function rule for this. Remember how to start. We're going to write it in function notation. So I'm going to write P of J. The total peanuts equals.
This makes me want a sandwich.
Hey, somebody use the 770 and the J and write the function rule to find out the total number of peanuts. You guys can do this. Harrison, what do you think?
P of J equals 770J.
Perfect. Guys, don't we just take the number of jars and multiply by 770? What do you guys think? Okay. Here's my question, you guys. How many peanuts are in 7 jars?
Oh, ugh.
I
That's a
don't know.
What
lot.
do you do? You find P of what number?
J.
7.
No, not P of J.
7.
5,390.
You find P of 7. You would go 770 times 7. You take your 7 jars. You take your 7 and plug it in for J. Okay? So, calculator or no calculator there, people?
Calculator.
Definitely calculator. Guys, what's P of 7?
Billy has it.
5,390
5,390? Label that, Bill.
peanuts.
Peanuts. That's a lot of peanuts. Okay? So, we're talking about independent and dependent variables.
Hey, Rocco's back.
Where's Rosetta?
Rocco never
Tasha
left.
was really mad about that.
All right, let's try another one of these. This one seemed a little bit easier.
He's just like, what kind of name is that? It's like
That's
Rosetta,
weird.
Rocco.
You guys just have 3 pages, right?
Yeah.
Yeah.
All right. Rocco.
Why not like Rocky or Rambo?
Who wants to read us?
Oh,
Start chapter 4.
tuna fish.
Oh.
Go ahead, pedal cow.
Rocco buys a can of tuna fish that weighs 4.2 ounces. Total weight, W of C, is a function of the number of cans of tuna fish, C.
Okay.
Dot.
So the total weights, W of C. It's a function of the cans, which we know to be C. Okay. All right. Let's see if we can identify the independent and dependent variables. You're going to get better at this. All right. Independent, dependent. Which one depends on the other? if you're confused about it, and a lot of you guys are that right now, that's okay. Say it both ways. Does the weight depend on the cans, or does the cans depend on the weight?
The weight depends on the can.
The weight depends on the cans. It's so clear that way. Let me say it again. If you're confused about which one's dependent, which one's independent, say, does this one depend on that one, or does that one depend on this one? Does the weight depend on the cans, or do the cans depend on the weight?
Weight depends on the can.
The weight of all of it depends on how many cans. So the weight, okay, is the dependent, because it depends, the independent, on the cans. I'm going to write the variables in there too. C and the weight is W of C. Okay? The cans, you can plug in any amount, any number of cans, and you will then get the weight. Okay? You would not plug in the weight and then get the cans. It doesn't make sense that way. All right. What values of the domains of the range make sense for this situation? Again, the domain and the range. The domain are the cans and the range are is the weight. Okay. So the domain, which is the cans, what number of cans could we buy? What numbers could there be for cans?
1, 2, 3,
Arms.
4.
Whole numbers. Could you buy 0
Yeah.
cans? Sure. That's considered a whole. You cannot buy a half of a can of tuna. It would just really gross if people do that at the store.
Ew.
Okay?
Like you say something like taking a tuna.
Hey, what's the range? What could the numbers be for the weight? Decimals, but more specifically, you're right about that.
Multiples of 4.2.
Multiples of 4.2. You guys got it. Multiples of 4.2. The weight is always going to be a multiple of 4.2. It's going to be 4.2, 8.4, 12.6, 16.8.
20
This is kind of like really screwy.
So I think it might be right on the money at the
20
next one.
point.
21.
21.
Wouldn't it be 21 times 5?
Yeah.
Yeah,
I
5
think-
cans would be 21.
I
So
think
eventually it
it's
does
really
work
good
out.
for
But the weight is always going to be multiples of 4.2. All right, now, this is the one you guys are all going to get. Write the function rule to represent the total weight of C cans of tuna.
Of 30.
CW or C or W.
Right, W of C equals. Try to write the rule. What's the weight always going to be? What do you guys think?
4.2.
No. 4.2 times something. Use C instead of 30. Because I want it for C cans, not 30 cans yet. Let's write the rule. 4.2 times C cans times C. Okay? The weight will always be 4.2 times how many cans you have. What if we buy 30 cans of tuna?
Oh, that's a lot of tuna.
So we're going to find W of
30.
30. Remember, we plugged that value in for C. It's going to be 4.2 times 30. Okay? Definitely need your calculator there. Somebody tell me the weight of 30 cans. I don't know how much that is. Natalia? Label it. 126 what? Ounces. Hope it's not 126 pounds of tuna. That would be weird. 126. It's in ounces.
It's 7.88
Okay.
pounds.
Confused.